Hi students, in this video I'll be going through the 2013 paper 1 question 13, okay, from the O-level mathematics paper. Right, so this is a question related to properties of circle. Okay, so let's read the question. So in the diagram, ABC is a tangent to the circle. So D is a point on the circumference of the circle, and angle BDC equals to 53 and angle BCD equals to 39. So explain why BD is not a diameter of this circle. Right, so for questions whereby they ask you to explain something, right, you need to be very clear about the concept that they are testing you about. Alright, so over here, a very important thing to know is that there's a tangent inside this question, right? Okay, so you need to think about the properties of circles that are related to tangent. So basically, there are only two of them. Alright, so one of them is a tangent from external point. Okay, but for this question, it can't be tangent for external point because there's only one tangent. Okay, tangent for external point requires two tangents. Right, so it has to be the other property, which is tangent perpendicular to radius. Right, so tangent perpendicular to radius, right? Okay, so over here, we know that tangent, if it's perpendicular to radius, then the angle DBC should be 90, right? Okay, so basically this is what we are going to do. We are going to try to find angle BDC, and if it's 90, then BD should be the diameter. Okay, but now they ask us to explain why it's not a diameter. So we should expecting angle DBC, right, to not be 90 degrees, right? So our immediate aim now would be to try to find angle DBC. Okay, so if DBC is not 90, then we know that dB will not be the diameter. Okay, because if dB is the diameter, means it passes through the center. Okay, if it passes through the center, that means the diameter is just 2 times of the radius. So then tangent perpendicular to radius property will then kick in, and then it will be 90 degrees. Right? So let's go ahead and try to find angle DBC. Okay, so we can find angle DBC very easily. Okay, by just using angle sum of triangle. Okay, so we can just take 180 minus away the other two angles, and then we will be able to find DBC. So you should be able to get DBC to be 88. So indeed it's not 90. Okay, and this would mean that DB is not the diameter. Okay, so now we just need to write a concluding statement to explain what we mean now. Okay, so since angle DBC is not equals to 90 degrees, okay, DB is not a diameter of the circle. Okay, so let's go ahead and elaborate, okay, to show that we understand what we are saying. Okay, so a diameter of a circle, diameter of the circle should be perpendicular to the tangent at B. Okay, so now we are saying that if BD is indeed a diameter, then it should be perpendicular. But in this case, it's 88 degrees, okay, angle DBC, so it's not perpendicular, right? Okay, so it's, for explanation question like this, you need to be very clear about the concept that they are testing you about, right? So then you will know what to find and then how to explain, okay, based on what you have found, right? Okay, so let's look at part B of the question. Okay, so in the diagram, A, B, C, and D are points on the circumference of the circle. So A, B, C, and D are points on the circumference. ADE is a straight line. Angle ABD is 42, and angle CAD is 37. Okay, so find angle ACD. All right, so whatever angle they want you to find, you should just mark it out on the diagram. Okay, then we ask yourself, what angle is this? So this is an angle at the circumference, right? And it's formed from the points A and D. So from A and D, you extend, okay, to the point C, then you form this angle, right? Okay, so you must ask yourself what properties are related to this. Okay, so from A, we extend outwards and we hit the circumference. Then from D, we also extend outwards and we hit the circumference at the same point C, right? So we form an angle over here. Okay, now if you go backwards to A and D, and if from A and D, right, you can extend to another point on the circumference, which is in the same segment, right, as point C, then we will be able to apply the property angles in the same segment. Okay, so once again, you just put two fingers, one at A and D, you move towards C. Okay, now you move back to points A and D. Okay, then from A and D, you move your fingers to another point, B, right? Okay, so in other words, ABD and ACD are angles in the same segment. Okay, so over here. Okay, so why do they call these properties angle in the same segment? Okay, because if you were to draw this line, a line across AD, right? Okay, it's going to divide the circle into two segments. One is the big segment over here, and another one is the small segment over here. Okay, this small segment which I'm going to shade now. Okay, so both the angles, right, that you have formed at the circumference lie on the same big segment. Okay, the one that is unshaded. That's why we call angles in the same segment. Okay, so let's go ahead and write the working. So angle ACD equals to angle ABD. Okay, so the property you always write in the working step, not at the final answer step. So this is because of angles in the same segment. Okay, so this would be 42 degrees. Okay, so just like this. Okay, within one step, you can get your answer. Okay, so once you have found the angle, you can actually just do it in the diagram. Okay, the next one would be to find angles CDE. Okay, so this one is also a 1-mark question, which means that the working can't be that long. So the angle that we want to find is over here. Okay, this CDE. Right, so CDE, as you can see, right, is an angle that is outside a triangle. Okay, basically which triangle? At triangle ACD. Okay, so we should be thinking about the property, exterior angle of triangle equals to sum of interior opposite angles. So where are the two interior opposite angles? So the interior opposite angles will be the angles that is opposite the side, right, that is touching CDE, which means that, opposite the angle CDE, which means that it's going to be this angle and this angle. Okay, so it can't be the angle that is adjacent to CDE, which is basically CDA lah. Okay, so it's the other two angles. Okay, so how do we apply this property? Okay, exterior angle of triangle equal to sum of interior opposite angle. So let me draw a separate diagram over here, okay, to explain this concept to you. Right, so let's say this angle is A and this angle is B, right? So can we express this angle in terms of A and B? Okay, so if we want to find this angle in terms of A and B, it's going to be 180 minus A plus B, right? Okay, because angle sum of triangle is 180. Okay, let's say this angle is C. Can I express that same angle, right, in terms of C now? Okay, so now there are adjacent angles on a straight line, right? So it will be 180 minus C. So in this case, we can see that C will be equals to A plus B. Okay, so in this case, C equals to A plus B. Okay, so A and B are the interior opposite angles to C, right? So we can apply this angle. So in this case, angle CDE will then just be 37 plus 42. Okay, so let's write down the working. So angle CDE will be equals to angle. Okay, let's write down the full working. CDE equals to angle DAC, right? DAC plus ACD, right? We can write CAD or DAC now. Okay, CAD plus angle ACD. Right, so angle CAD will be 37, angle ACD will be 42. Okay, so if you add them together, you'll get 79 degrees. Okay, so the reason you'll write exterior angle of triangle equals to sum of interior opposite angles. Right, so remember the working, the reasoning always write in the working step, okay, not at the final answer step, because the working step is what we want you to explain. Okay, why do you show that working in the first place, right? Okay, so this is the solution for this question.